You have two objectives today. One, you need to be able to recognize polynomials which are prime. Number two, you need to be able to factor polynomials completely. And we will talk about exactly what completely means. Let's go back to this page. Which of these polynomials are prime? Here's the word prime. What does prime mean? Prime means that it cannot be factored. If a polynomial can be factored, what does factored mean? It means that it can be split into parts that are multiplied by each other. Okay? Factors get multiplied by each other. So let's take this polynomial. Can it be factored? Yes, it has a GCF. Is this one prime? No, this is not prime. This is not prime. This is not prime. This is a difference of two squares. We can factor this one as x plus 3 times x minus 3. How about this polynomial? Can it be factored? Well, it's a trinomial, so let's do the x and the box. We do the box first, I like to. We put our x squared in, we put our 25 here. Now we need to split the middle term. So up here goes 25x squared. That's the attic. In the basement, we get 10x. Two numbers that multiply to 25 and add to 10. We've got 5x and 5x. So we fill them on in. Greatest common factors. Oh, look what we have. X plus 5 times x plus 5, or x plus 5 squared. Did you notice that that was a perfect square trinomial? If you did, you could have gone straight to this pattern. All right, let's try this one. Can this one be factored? This looks a lot like a difference of two squares, but it's not a difference. Difference is subtraction. This is a sum. Sum is the answer when you add. This one cannot be factored. Binomials can only be factored if they have a GCF or if they are a difference of two squares. How about this one? No, this one's prime as well. It cannot be factored. One more time, prime means it cannot be factored. It cannot be split into parts that are multiplied by each other. It does not, that means how do you check to see if it's prime or not? It's only prime if there's no GCF, if it can't be split by grouping, if it's a trinomial, the x won't work. You won't be able to split those middle terms. And if it's a binomial, if it has no GCF and it's not a difference of two squares, then it's prime. Okay. Let's try this one. Here are two polynomials. Each of them have 4 terms. Which one is prime? Let's try this one to start. 5x cubed, 3x minus 21x minus 4. Greatest common factors, I've got a 3x here, I've got a 1 here, I've got 3x here, I've got a negative 1 here. I check, does my multiplication work? No. So then I say, did I make a mistake? Did I make a copy error? Oh, I did, look. Does that help me out? No, my multiplication still doesn't work. Maybe it's prime. Let's try this one. Okay, greatest common factors, 5x, 1, 3x squared minus 4. Check the multiplication. Does it work? It does. Yes, this one can be factored. I can write it as 3x squared minus 4 times 5x plus 1. This one, prime, cannot be factored. Let's try this. I should have written which ones are prime. Let's try it. Notice the same. The only differences are the middle terms here. So I'm going to put negative 24x squared as the top term in each of these. And in the bottom, I've got my negative 3x, my negative 5x, my negative 7x. Okay? Let's split. Can you think of two numbers which multiply to negative 24 and add to negative 3? That's hard. Well, before you give up, don't just say it's prime. Let's think about what are the prime factors of 24. 24 is just 8 times 3, and 8 is 2 times 2 times 2. So 24 is 2 times 2 times 2 times 3. So all the possibilities are 1 and 24. That would be all these factors together. I'm going to pull a 2 out now. 2 and 2 times 2 times 3 is 12 left over. I could have a 3 by itself. That would be 3 and 8. I could take two factors together at a time. Let's try 4 times 6. Any other possibilities? That's it. I know that I need to have negative. I need more negatives than positives. I know since the top is negative, I need one negative, one positive. So let's put negatives here, 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 and here. Do any of these pairs add up to negative 3? No. This one is prime. How about here? Yes, this one, I can see a pair that will work. 3x minus 8x. How about here? Any of those pairs add up to negative 7? No. This one's prime. Do not say it's prime unless you've gone through all the possibilities. All right. Quick review. Let's take out all of these. This is your factor tree. First step in factoring is always to look for a GCF. Then you think about the number of terms. If it has 4 terms, you need to use an area model to do your grouping. If there's 3 terms, you're going to do grouping, but you need to split that middle term, you need to use the x. If it has 2 terms, it has to be a difference of 2 squares. A plus b times a minus b. Okay, let's give this one a try. I'm going to do this first. Oh, it's not working. There we go. First step. We need to factor out the GCF. 4 times k to the 4th minus 16. What's left inside the parentheses is a binomial. That's 2 terms. So let's keep the GCF on the outside. Let's split this into a plus b times a minus b. I'm going to call this one k squared plus 4, k squared minus 4. Now I look again. I still have binomials. Can this one be factored anymore? No, that is a sum of 2 squares. That one cannot be factored. But look, I still have a difference of 2 squares. This one can still be factored. So I keep the 2 factors I already have. And I'm going to split this third one. This becomes k plus 2 times k minus 2. I just want you to take a look at something. I'm going to turn this into a factor tree. All I've done here is I took our polynomial and I rewrote each step of our factoring. First, we took the GCF out. Then we factored this part into 2 smaller factors. Then we took this factor and factored it into 2 smaller factors. prime factor. It can't be split anymore. It could be split into 2 times 2. This was a prime factor. It couldn't be split. This was a prime factor, and this was a prime factor. Okay? That's how factoring works. I think I can do one more. Just a moment. All right, let me see if I can split this into as many factors as I can. First step, find the GCF. I've got a 4 that goes into all 3 terms. Also look at the variables. I've got a k that goes into all 3 terms. What's left is k squared plus 2k plus 1. Now I see if I can factor what's left inside here. So let me go over to the side. All right, so we've got the trinomial. We're going to factor it. We start with an area model. Put in k squared. I put in 1. Now I need to split the 2k. I need my x. I put in a times c is k squared. I put in the basement 2k. 2 numbers that multiply to 1 and add to 2. That's just going to be 1k and 1k. Oh, now I realize maybe I had a perfect square trinomial. I do. K plus 1 squared. So this was 4k times k plus 1 times k plus 1, or I could just write it as this. Okay, last example. First I check, is there a GCF? A number that goes into all 4 terms. First check the numbers. No. Then check the variables. No. So let's use an area model. In here I've got 4k squared, 1k, 2. Double check your multiplication. Does it work? 8k squared, k, yes it does. This one factors to k plus 2 times 4k squared plus 1. Good? Let me show you that one as a factor tree. You don't need to do a factor tree at all, but I'm going to show you. Oh, one quick thing. Notice these binomials. Can this factor anymore? No. Can this factor anymore? No. This one is a sum of 2 squares. It will not factor anymore.